An introduction to statistical process control. Process control is used to monitor a production process. And in the production process, we have a set target that we are aiming for. So is our process deviating from this set target? Or is the item-to-item variability increasing? So we can take regular samples from the production process. We can analyze the samples to check for a mean, the sample mean, and the range or standard deviation to check for the variability in the process. In an ideal situation, we would want our sample to show that the exact set target has been achieved and that the variation in the process is 0. In reality, we aim to be as close as possible to the set target, and we aim for a small standard deviation. There is always some natural variability in every process. So aiming for a 0 standard deviation is unrealistic, but we can accept a small standard deviation in the production process. Here we have 3 bottles of cola. They should all contain 2 liters. On closer inspection, we can see that this bottle has slightly more than 2 liters, and this one has slightly less. Our process control, where we take regular samples, can show us whether we are achieving our set target. So we take a sample and we measure the mean of that sample, and we do this at regular intervals. And that data can be plotted onto a graph called a process control chart to look for short-term changes in our production process. For variability, we're aiming for a low value. So we could be measuring range or standard deviation for variability, but a small value is desirable. The smaller the better. Again, it's regular samples that will show us whether we are achieving a small variability or not. Here is a control chart for the mean. 5 samples were taken. Here is sample 1, and the mean for sample 1 is plotted. Sample 2, the mean for sample 2 is plotted, and so on. Our target value for this product, so we're not looking at the cola bottles here, is 153. We can calculate values called the upper and lower warning limits, so we can draw these upper and lower warning lines on our control chart, and we can do something similar with upper and lower action limits. So what does this all mean? Well, if our sample mean value falls in between the warning limits, then everything is fine. If the sample mean falls in between the warning and action limits, so either here or here, then we should take another sample immediately. And if the new sample mean is also outside the warning limits, then we need to take action. Then we stop the process and take action. if the sample mean falls outside the upper action line or below the lower action line, we stop the process immediately and do something. Something has gone wrong in the production process and changes need to be made immediately. In this example, this sample mean shows the process is working fine, and so does this one. This value is in between the warning and action limits, so another sample is taken immediately. And the second sample here is above the upper action line, so we would stop the process and do something. So the process here was stopped, some changes were made, but then the next sample taken is also between the warning and action limits, but at the lower end of our control chart. So perhaps the machine was over adjusted earlier. Here is a control chart for standard deviation. And standard deviation is measuring the variability in the production process, and a low variability is desirable. So values at this end are desirable and not at this end. There is no set target limit for the standard deviation. If there was a target, it would ideally be 0. So our first sample standard deviation value here is within our warning limits, so that one's fine. The next one is in between the warning and action limits, so we should take another sample immediately, which we do here. And this one is also in between the warning and action limits, but the value is low this time, so this is good. If we have a value that's in between the lower warning and lower action limits, we should still aim to take another sample immediately with the aim of maintaining our improvement. This value is above the upper action limit, so we should stop the process immediately and take action. So let's say after this one the process was stopped and changes were made, and this is the next sample taken. It's within our warning limits, everything's working fine. And here's a control chart for variability. This time we're looking at the range as a measure of variability in the process, and again for values which fall within the warning limits, everything's fine. Values which fall in between the warning and action limits, we should take another sample immediately. So this one here is showing that the range is getting larger, so something might be about to go wrong here. This one here, again, it's between the warning and action limits. It's a smaller value, it's at the lower end, and we should take another sample again here with the aim of maintaining an improved process. Yeah, we're looking at a situation where we want to maintain the improvement. That one's too high. It's above the action limit, so stop the process and take action immediately. And this one's within the warning limits, so this one's fine. Worked examples with calculations for everything that you've seen in this video will be in our next video. The aim of this video was just to introduce some basic concepts of process control. We're not looking at calculations here.